Pressure is also an important term which is related to fluid mechanics, and the pressure of a liquid at a point is the thrust or normal force. Pressure at a point in the liquid is the thrust or normal force acting at that point on the liquid surface. So pressure at a point is the thrust exerted by the liquid at rest per unit area around that point. The normal force acting at that point per unit area on the liquid surface. Because pressure is force per unit area, so normal force, we are discussing about normal force acting at that point. Suppose I am taking an example. Suppose there is a liquid, and in a container we had placed a liquid at rest, and suppose this is point P. So the liquid at this point P exerts force. This liquid at point P exerts force in all directions, and this is the area, this is the surface area for which the liquid is applying the force. So for the force per unit area, that is called the pressure. Normal force per unit area, and normal force is what? Normal force is thrust. So pressure can be defined as thrust upon area. Pressure can be defined as thrust upon area, or P is equal to F upon P is equal to what? Pressure P is equal to what? F upon A. F is what? F is the normal force. F is the normal force. Its unit is dyne per centimeter square, that is the CGS unit. Newton per meter square, it is the SI unit, and Newton meter square is called as Pascal. 1 Newton per meter square, it is called as 1 Newton per meter square, it is called as 1 Pascal. So this is about the unit, and its dimensional formula is force, dimension of force MLT minus 2 and divided by L square. So L minus 1 T minus 2. Its dimensional formula is ML minus 1, because force has the dimension MLT minus 2 and it has the dimension L square, so it will go upside. So it will become L minus 1 T minus 2. So this is about the basic of pressure. Now 1 Newton per meter square or 1 Pascal or 1 Newton per meter square is equal to 10 dyne per centimeter square. Yes students, now this is about the pressure and its dimensional formula. Now the another common unit of pressure, another common unit of pressure, another common unit of pressure is atmosphere. Atmosphere, and 1 atmosphere, yeah, 1 atm, 1 atm. What is 1 atmosphere? Means whatever the pressure exerted by the atmosphere on the unit area at the sea level, that pressure is called as 1 atm, and 1 atm is equal to 1.013 into 10 to the power 5 Pascal. 1.013 into 10 to the power 5 Pascal. So this is the value of atmospheric pressure, and this atmospheric pressure can be denoted by atm, and 1 atm is equal to 1 atmospheric pressure is equal to 1.013 into 10 to the power 5 Pascal. Now we will discuss about, suppose all these things we had discussed, that there is a container, this is a container we had taken, and the liquid at this point, the molecule or liquid at this point, the molecule of the liquid which we had considered at this point P is exerting force on an unit surface area uniformly, but suppose there is a condition that if this force is of variable nature, then what we will do? Then how can you calculate the pressure? Then pressure can be calculated by, if the force is not distributed uniformly over a given surface. If the force is not distributed uniformly over the given surface. If the force is not uniformly distributed over a if the force is not uniformly distributed over a given surface, and if force is not uniformly distributed over a given surface, then the pressure will exert different amount of pressure in different directions. So in a particular direction, if the force we are supposing delta F is the force exerted in a certain area delta A, then pressure can be given as differential pressure. This is called as differential pressure, because in different directions we are getting different pressure, so I am taking a differential, and this differential pressure is given as limit delta A tends to 0 del F upon del A, and it can be given as dF upon dA. This is about differential pressure, because in the previous case we had discussed that if the force is acting on the particular area or particular unit area uniformly, then we had given it as pressure is equal to force upon area, the force is acting constant. But if the forces are not uniformly distributed, or due to some reason, in various regions the forces are varying, then in that case we will discuss about the differential pressure, and that differential pressure is equal to dF upon area. Now pressure is a scalar quantity. Pressure is a scalar quantity. Why pressure is a scalar quantity? Pressure is a scalar quantity because the magnitude of pressure in case of liquid, if we are talking about the liquid pressure, then the magnitude of pressure in different directions inside the liquid is the same, because with the direction the pressure is not changing. So we say that pressure is a scalar quantity. Now dear students, we are going to discuss very important concept regarding the fluid mechanics, and the fluid mechanics is based on this concept, that is Pascal's law. Pascal's law. Look for the Pascal's law. What does the Pascal's law says? Pascal's law. Pascal's law. A famous French scientist, Blaise Pascal. French scientist Blaise Pascal. Blaise Pascal. He had performed a series of experiments, and on the basis of that experiments he had concluded that when an object is placed at a particular height inside the liquid, then whatever the pressure exerted by the liquid on that object, the value of pressure will be same. Means to say that, suppose there is a container. Here I am taking a container, and in this container there is a liquid is kept inside this container, and any object, suppose any object is placed at height h of the liquid, then whatever the pressures exerted by the liquid in different directions, suppose this is P1, P2, P3, P4, all the pressures P1 is equal to, P2 is equal to, P3 is equal to, P4. All the pressures will be same in that liquid. So after the series of experiments performed by Sir Blaise Pascal, he had quoted one law that is called as Pascal's law, and on the basis of Pascal's law it was says that at a given height, pressure exerted by the fluid is same in all directions. Pressure exerted by the fluid is same in all directions. It is the liquid at rest at a given height. If the liquid is at rest, condition that if the liquid is at rest. Okay, students. So now we are going to prove this Pascal's law, so we will look for the proof of Pascal's law. Look at how he had proved the Pascal's law, and what he had done. He had taken a container. He had taken a container, and inside that container, he had taken a container, and inside this container, he had taken a triangular prism. He had taken a triangular. He had taken what? He had taken a triangular prism. He had taken a triangular prism A, B, C, D, E, F. Now, he had taken the force, suppose Fc is applied here, Fb is applied here, and Fa is applied here by the liquid on the surface of this triangular prism. Okay, students, the prism is very small. He had considered it very small, and it is at the same height from the bottom of the liquid. These things we had considered. Okay? The height is not changing, and all these things we had considered, we had supposed. Prism is of very small dimension, so that the height of the prism from the bottom of the liquid is same, and the force exerted and on the surface of the right triangular prism is Fa, Fb and Fc. Now, resolving Fc, I am resolving Fc because this is the level of the liquid, this is the surface, and Fc is acting in this direction. So Fc is acting in this direction, so this angle will be this. Suppose I am taking this angle will be theta. So this angle will be theta, and if this angle will be theta, then this component is Fc cos theta, and this component is Fc sin theta. Fc cos theta and Fc sin theta. Now look at here, we had resolved Fc. Now applying the Newton's second law, applying the Newton's law here, Newton's third law, applying Newton's third law, then by Newton's third law we can say that by Newton's third law, by Newton's third law, by Newton's third law we can say that Fc sin theta, Fb is equal to Fc sin theta, because the liquid is at rest. We had considered the liquid is at rest, so net force is Fb is equal to Fc sin theta, and Fa is equal to Fc cos theta. Fc is equal to, similarly by geometry, because area is also a vector, area vector we will consider the normal to the surface. If there is any surface, then the area vector is normal to the surface. So here, if we are considering the area vector, then we can also resolve it by geometry. By geometry we can also resolve as AB, area of section B, AB is equal to AC sin theta, and AA is equal to AC cos theta. Okay, students. Now, suppose this is equation 1, this is 1, and this is 2. This is 1 and this is 2. Now, what we will do? Dividing both, Fb sin, okay, Fc we had considered it. So look at here, Fc sine theta upon AC sine theta, that is equal to FB upon AB, and similarly FC cos theta upon AC cos theta, and this is equal to what? AA upon, FA upon AA. Now sine to cancel out and cos to cancel out, and look at here, FC upon AC is equal to FB upon AB, and FC upon AC, that is equal to FA upon AA. And now we can say that PC is equal to PB and PC is equal to PA. Now look at here, two things are equal to the same thing, so we can write that PA is equal to PB is equal to PC. Means we had proved that if the solid is at the same height from the liquid surface, then the pressure in all the directions will be same. So we can say that pressure exerted by the fluid at rest on a body, pressure exerted on a body in a fluid is same at equal height. So this is all about the Pascal's law, student. If a liquid is placed at certain height, then if a solid is placed at certain height, then pressure exerted on the solid by the liquid at that height will be same in all directions. So we had proved PA is equal to PB is equal to PC. So dear students, that's all for today. Now in the next video we will discuss about the variation of pressure with G, or you can say that the variation of pressure with height we will discuss, and after that we will discuss certain numericals based on this. Thank you students, have a nice day, take care.